Alright, in this video I'll be going over Chebyshevs Inequality. I don't know if that's how you say it, but it sounds pretty cool, so I'm going to go with it. It says here, for any data set or distribution, at least 1 minus 1 over k squared times 100%. So basically just take this value in the parentheses, which will be a decimal, and turn it into a percent. But at least that percent of the observations lie within k standard deviations of the mean, where k is greater than 1. The strength of Chebyshevs inequality is that it can be used regardless of the shape of the data. So it's not as accurate as if we have a normal distribution or a bell-shaped curve. But it can be used with any shape, and so that's its value. On the other hand, if you have a normal distribution, you would want to do things the way we've been doing them. Alright, and the other thing that's kind of nice about this is it's pretty easy to do. So let's go ahead and use this on a problem. So here's an example. It says at one point the average price of regular unleaded gasoline was $3.63 per gallon. Assume that the standard deviation price is 5 cents per gallon and use Chebyshevs inequality to answer the following. Alright, so I'm going to go ahead and switch to a different paper and we're going to do all our work on there. Whoops, let's adjust. So same question. Let me just go ahead and focus this in a little bit better. Alright. So what percentage of gasoline stations had prices within 3 standard deviations of the mean? Round to 2 decimal places. So first of all here we have k equal to 3. Remember, k just needs to be greater than 1. So all we need to do is plug in, so we have 1 minus 1 over k squared, and in this case that would be 3 squared. And again, that's times 100%, or you can think of it as we're going to change this decimal number into a percent. So if you do that, you'll find that you get 0.88888. Since we're going to round to 2 decimal places and this has to be changed to a percent, we'll move the decimal 2 places, and so we're going to need 3 places to the right of the decimal. And so basically this is 88.888%, which we would round to 88.89%. So what this is saying is at least 88.89% of the data, or of the gasoline, whoops, let me fix that. Stations had prices within 3 standard deviations of the mean. Now, when you do this problem, or a problem like this in my math lab or my stat lab, it'll just ask you for this part, but I just want to make sure you understand what it's saying here. At least 88.89% of the gasoline stations had prices within 3 standard deviations of the mean. Alright, so let's move on to the next one. It says, what percentage of gasoline stations had prices within 1.5 standard deviations of the mean? And then it says, what are the prices that are within 1.5 standard deviations of the mean. Well, let's go ahead and use Chebyshevs rule here. Notice this time k equals 1.5, and so it'll be 1 minus 1 over 1.5 squared, again times 100%. So go ahead and put that into your calculator. You should get 0.55555. Again, we want to go to 5 plus decimal places because we're going to move it 2 to turn it into percent. And we need to round to this place here, and so we'll need that digit there. And so this is 55.56%. All right. Now it says, what are the prices that are within 1.5 standard deviations of the mean? Well, let's look at the price that's 1.5 standard deviations above the mean. So 1.5, I'll just put SD for standard deviations above mean, and 1.5 standard deviations below the mean. So we don't actually need our formula here. All we need to do is take the mean, which is 363, and we're going to add 1.5 standard deviations where one standard deviation is 5 cents. We have that up here. So if one standard deviation is 5 cents, half of 5 cents would be 2.5 cents, or 0.025, right? Just divide 0.05 in half. And excuse me. So you could add 0.05 and then add 0.025. Probably the easiest way, though, is to multiply 1.5 times our standard deviation, which is 5 cents. You get 3.63 plus 0.075, which is 3.705, which we're going to round to $3.71. Let me just double check my work. I think I did that right. Okay. So then to find the value that's 1.5 standard deviations below the mean, you take the 363 and subtract 1.5 standard deviations. And here you should get 3.555, which rounds to $3.55. So it said, what are the prices that are within 1.5 standard deviations of the mean? We would just say between 350. Oops, I rounded that wrong, didn't I? That's 356. 356 and 371. Let's see, this was our other answer here, and this was our answer up above. All right, let's go ahead and look at C. It says, what is the minimum percentage of gasoline stations that had prices between $3.53 and $3.73? So I know it's not necessarily a normal distribution, but I'm going to draw it just because that's the way we're used to doing this. We know the distribution could be something that's not a normal distribution, but the main thing we're focused on is the mean and standard deviations above and below the mean. So we know the mean is 363, and normally the 3 standard deviations gets you to the tail. And same thing over here, so we want to have 3 marks on each side of the mean. So if we add 5 cents, we'll get 368. So this is basically at 0 standard deviations. This is 1, 2, and 3. So we'll add another 5 cents. We're at 373. And you can see that we got that one there. Let's go the other direction. If we subtract 5 cents, we get 358. And subtract 5 cents once again, and you get 353. And so you can see this is minus 1 standard deviation and minus 2 standard deviations. Whoops, I'm sorry, you couldn't see that. So again, we don't know what the standard or the distribution looks like, but this is our standard deviations above and below the mean. 2 standard deviations above the mean, we're at 373. 2 standard deviations below the mean, we're at 353. And we wanted to know the minimum percentage of gasoline stations that had prices between these two numbers. So that's 2 standard deviations. And so what we found is that k equals 2. And notice it's asking the minimum percentage. So in other words, remember with Chebyshevs Inequality, it's at least a certain percentage. And so that's what they mean by minimum percentage here. So we're going to plug in 2. It'll be 1 minus 1 over 2 squared times 100%. And you're going to get 0.75 or 0.75 times 100%, or 75%. And so that is our answer, and that's it for this video.